Right, we've got two equilibria here. What reaction will take place? Remember, these are both showing reductions. One must be reversed. Which one has got to be?
Mg and Ni2+.
Yeah. So this one is the more. They're both negative, but this one is the more positive. So that one's going to go that way. That one's going to go that way. So the reaction that will take place, magnesium will react with nickel 2+ to give me nickel metal and magnesium ions. Does that make sense to us as experienced chemists?
Nickel won't want to go that way. But what's like the question that you get asked?
Well, what reaction will take place? So they may say, will magnesium react with nickel 2+?
Yes.
And it would be, will it react with nickel 2+? And the reason being, yes, magnesium will react with nickel 2+ because this one will go from left to right and this one will go with reverse.
So it's comparative.
Yeah. So, however, if I took nickel and magnesium 2+, that wouldn't work because they're my products. So, what reaction will take place? Magnesium will react with nickel 2+, give me nickel and magnesium. What would be the voltage on my voltmeter? So I need to know the difference between those two. So it's minus 2.36 volts and minus 0.25 volts.
Which one do you minus from each other? Because you get a different.
One positive, one minus the.
Yeah, so what's the difference between those? The difference is going to be 2.11 volts. So, we'll test that in a minute, but in terms of chemistry, you know that magnesium is a very reactive metal, don't you?
Yes.
Whereas nickel isn't a very reactive metal. So if you think about year 9 chemistry, this is what you would have called a displacement reaction of metals, and you would have been able to tell me that because magnesium is a more reactive metal, it will displace a less reactive metal from its solution to become the ions. So, you're happy with that? One of these you must always reverse because they both show reductions. Okay, let's do it. I've got magnesium 2+ ions here with a bit of magnesium in, nickel with some nickel 2+. Let's connect these out straight away, nothing at all because I need my salt bridge. So let's do it, soak it through, ready, steady, go. What do I see? Ooh, it's 1.6 volts. That's a bit lame, isn't it? We predicted it to be about 2.11 volts. Okay, it could be better, could be worse. Maybe the one of the things that can go wrong is sometimes the metal gets a bit corroded, so you haven't got very good contact. So it's where, particularly with our old ferromagnesium, because it's quite reactive. It does look a bit dodged, doesn't it? Yeah. But that's what. And what would be happening is the electrons are going to my nickel 2+, and that's becoming nickel. And magnesium is giving up its electrons, becoming magnesium 2+. Okay.